Welcome to the video on how to do hydrocarbon combustion reactions. These are super easy. So I'm going to take this opportunity to kind of teach you something in addition to just writing the reactions. And that's just a real brief tutorial on how to name hydrocarbons, organic compounds. We know that hydrocarbon combustion reactions are a hydrocarbon fuel, and we burn it, which means react with oxygen. It's a very exothermic reaction. And the products are CO2 and water. And sometimes we can also see oxygenated hydrocarbons, but things still work out the same way. In either case, this is what we call an organic compound. There's lots of organic compounds, okay? I have no chance of explaining them all to you here, but I do want to introduce you to kind of the simple ones, the most basic ones. The most basic ones are called alkanes. And then there's a derivative called alkenes, which are still pretty simple and common. And then less common, but we'll do it here, alkynes. Now these are simple because there's no oxygen. So first of all, we don't have to worry about that in this naming system. It's just CX and then HY. And there's always a formula. Alkanes are saturated. You've heard of saturated fats, which means they can hold all the hydrogen possible according to our covalent bonding. Remember, carbon has 4 bonds to it. So if that's the case, there always will be 2N plus 2 hydrogens. So for example, if I have 1 carbon, I'll have 2N plus 2, which is 4 hydrogens. If I have 2 carbons, I'll have 2 times 2 plus 2, which is 6 hydrogens. And then we'll do one more. If there's 3 carbons, 2N plus 2 is 8. Alkanes are similar. Whereas the alkanes have all single bonds, the alkenes will have a double bond in there somewhere. And because you have a double bond, you have the carbons that are new hybridized, you don't have as many hydrogens. And so the generic formula is CN, just H2N. So there can be no single carbon alkene. The simplest one is C2 and then H4. And then if we had C3, it would be H6. Same thing with alkynes. Alkynes are where you have at least 1 triple bond. The simplest, or the generic formula for alkynes are CnH2n minus 2. The simplest alkyne is C2, and there would only be 2 hydrogens. And that's called acetylene. I'm sure you all have heard of acetylene. So the naming system I want to go through just real briefly is based on how many carbons there are. So if you look at these alkanes that I've listed, this one is called methane. The second one is called ethane. The third one is called propane, and I'm sure you've heard of all these words before. If I did another one, C4H10, that's called butane. I know you've all heard of butane. And those each have kind of a weird name. Now starting at 5, we don't have to worry about weird names. Now we pick up with our regular geometric prefixes for 5. Pentane, the next one will be hexane, heptane, octane, which you've heard of, nonane, decane, and so forth. So in a way, naming these organic alkenes is very similar to naming our covalent compounds because we had those prefixes that told us how many. For organic, 1 is always meth, 2 is eth, 3 is prop, and 4 is buta. In covalent, it was mono, di, tri, tetra. And then it picked up penta and just went crazy. Organic, it's just meth, eth, prop, buta, then penta, and then it goes crazy. So that's the only thing really different about it. I just want to make you somewhat familiar with that. That's going to help us, that naming system is going to help us with some of these, not all of them because there's just too much here. But number one, meth, we know is just one carbon. The ANE tells me it's an alkane, so it's saturated, 2N plus 2. So that's how you could, if you don't have methane memorized, you can figure it out real quick. But it's combustion, which just means plus O2, and we're going to make CO2 and water. We don't have to think about it. CO2 and water. And then we balance this. Remember our balancing trick for combustion reactions, subscript for carbon is 1, so that's what I put in front of CO2. Half the hydrogens in front of water, so I'll put 2 there. Count your oxygens up, 2 plus 2 is 4, so we put 2 oxygens there. Number 2, there's 2 carbons. They gave us the formula for it. What do you think the name of that is? Did you guess ethene? It is eth because there's 2, and since it's the CNH 2N minus 2, it's actually not ethene, I made a mistake. That is the acetylene that I showed you, also called ethyne. So anyway, it still burns the same way as the rest. We're going to make CO2 and water. And balancing this, 2 in front of CO2, half of that in front of water. We've got 4 plus 1, 5 hydrogens. So we're going to have to multiply the oxygen times 5 halves. And now you can multiply everything by 2 and get 2, 5, 4, and 2. All right, number 3 is methanol, CH3OH. You can see the hints of the methane in the CH3. That's methanol. It is a liquid. It's an alcohol, but it still burns, and we still get CO2, and we still get water. Balancing it, 1 carbon, 1 CO2. 4 hydrogens, 2 waters. Count your oxygens up, 2 plus 2 is 4. I have 1 already, so I only need 3 here. So make it 3 halves. Multiply everything by 2, 2, 3, 2, and 4. All right, number 4 is a very important molecule for combustion. Your body combusts this molecule all the time. Don't believe me, huh? There's no fire inside your body. Well, that's true because it's a controlled reaction inside your body. But that's glucose. And cellular respiration combusts glucose all the time. That's why your body produces heat. It is a combustion reaction. But we still get CO2 that you have to exhale and water that you have to urinate. All right, let's balance. 6 carbons, 6 CO2. 12 hydrogens, 6 waters. That is 18 oxygens. I already have 6 here, so I only need 12 here, so put a 6 there. All right, we're going to do a couple more here. These are very repetitive. Octane, what does oct mean? Yep, 8. So this is going to be C8, and because it ends in ANE, this is your 2N plus 2 formula, so this is 18. Octane is a liquid. It's the main component of gasoline. And we know it combusts CO2 and water. 8 carbons, 8 CO2s. 18 hydrogens, 9 waters. 16 plus 9, 25 oxygens, so I need a 25 over 2. Let's multiply everything by 2. Get some pretty big coefficients. Propane, I showed you just a moment ago, C3H8. Propane's a gas, believe it or not. When you buy propane at the store, it's under pressure, and that liquefies it. We've learned that through our IMFs, or in our gas laws. If we pressure it enough, it will liquefy through the LDFs. Still make CO2 and water. I can promise you we're not going to have a fraction here, and I know that because this is an odd number. 3 CO2s, 4 waters, 10 oxygens, so we'll use a 5. And that will always be true. All right, let's finish this up. We have C6H6, which is called benzene, a very important molecule. It's a very common molecule, believe it or not. It's in most of anything that you smell is aromatic. Usually begins or has a benzene ring in there somewhere. We'll learn more about that later. But again, CO2 and water. 6, 3, and I'm going really fast, make sure I don't make a mistake. I don't feel like multiplying that one by 2. Let's finish this off. Number 8, 2, so that's F. This is your N2N, so that's ethene or ethylene. I believe it is a gas still. O2, CO2, and water. The main part of this video, though, is that you understand that combustion reactions, as long as the fuel is a carbon compound, we get CO2 and water. So 2 CO2s, 2 waters, that gives me 6 oxygens. So there we go. It's combustion. It's pretty simple. Don't be too confused by the naming I went over at the beginning. If you don't understand that perfectly, it's not going to be a problem. It was a lot of FYI. But if you have questions, come see me.